Okay, class. In this session, we look into this. First, we look into the current. How can we define the current? Okay. So to define the current, okay, the definition of current. Current, before this, you had learned in your form 1. Okay, current is one of the physical quantity that had been introduced in your form 1. And in form 2 also, we had learned about current. Okay, so that's mean this is just quick revision about the current kan. Kita dah buat eksperimen dan sebagainya masa form 2 dulu. Okay, so let's look back into the current. So current can be defined as the rate of flow of charge. Okay, the rate of flow of charge. So dekat sini kita highlightkan the rate of flow of charge. So that is the definition of current. Okay, so current is the rate of flow of charge. When we talk about rate, okay, we will always refer itu to certain amount of time. Normally unit time lah. Okay, maksudnya kita nak tengok how fast, how many of charge can flow in 1 unit of time. 1 unit of time here meaning that maybe it can be 1 hour, 1 minute, or one day, and so on lah. Okay, but for SI unit we are using one second, of course 1 second. So that's mean current is the rate of flow of charge. Current will show how many of charge will flow in 1 second. That is the current in SI unit. Okay, meaning that if the current is high, such as 3 ampere, okay, 3 ampere, if you still remember the unit that is used for current, ampere, so that's mean, okay, there is 3 coulomb of charge flow in 1 second. Dalam masa 1 saat, maksudnya ada 3 coulomb charge. And if the current show the value of 1 ampere, that mean 1 coulomb of charge flow in 1 second. Okay, 1 coulomb charge mengalir dalam masa 1 saat. Okay, itu yang dimaksudkan dengan current. Okay, that's why we are using the word or the term rate. Okay, the term rate. Rate kita refer kepada time. Okay, so as you can see here, this definition of current can be easily obtained from this equation. Okay, if you still remember in your form 2, we have learned about this equation. Okay, we had been introduced about this equation, how we can relate the current with charge and also with time, where we can get the relationship between all of those physical quantity. Okay, so from the equation, if you still remember, Q equals to IT. Okay, this is how I memorize this equation. Okay, because it will be easier. Same just like I memorized this one, V equals to IR. If you still remember Ohm's law. Okay, so susunan dia sama kan, VIR QIT. So senang. Okay, so from this equation, we just take I and make it as our subject and rearrange the equation. We will get I equals to Q divided by T. Okay, so from this equation, if you still remember, maybe with my class 2EF, 2DEF kan, siapa yang kelas 2DEF dulu, if you still remember, from this mathematical expression, if you have divide by T, okay, kalau kamu jumpa sahaja bahagi dengan T, bahagi dengan masa, so in our definition, we should include the term rate, the word rate. Mesti ada perkataan rate. Okay, rate. Contohnya apa? Maybe after this, you will learn about, or in your form 3 kan? Kamu belajar apa change in momentum, right? Kan? Impulsive force. Impulsive force equals to mv minus mu divided by t. Okay, so ada divide by t. So dalam divide by t, bila kita nak define this impulsive force, mesti ada perkataan rate. Okay, the word rate. So you need to include the word rate. Rate of what? Rate of change in momentum. That is impulsive force. So for this one, current from this equation, from this equation or formula, we can get the definition of current. So current is the rate of what? Apa yang berada di atas dia. So this is Q is symbol for charge. Charge in coulomb. Okay, charge in coulomb. So rate of charge. Takkan nak tulis charge, dia tak cantik pula kan, rate of charge. So kita tambah lagi satu perkataan, rate of flow of charge. Kadar aliran objek bercharge. Charge objek. Berapa cepat objek yang bercharge boleh mengalir. Okay. Okay, that is how we can get the definition for current. Okay. The charge of an electron, normally it will be given in any question. You don't need to memorize the charge of electron, okay? Tak perlu hafal pun. So normally E is equals to 1.6 times 10 power negative 19 coulomb. When the number of electron is n, so we have another equation that can relate the total charge. So Q here is the total charge, n is the number, E is the charge of an electron. Okay. Contoh, kalau dalam kita punya mana tadi? Dah hilang dah. So if we look into our previous example, okay, I just gave you 3 ampere, right? Okay, 3 ampere. Okay, 3 ampere. 3 ampere represent 3 coulomb of charge flow in 1 second. Okay, 3 coulomb of charge flow in 1 second. So 3 coulomb here is only the charge. Okay, Q equals to 3 coulomb. Okay, if you want to find the number of electron, okay, electron, this is not the number of electron. 3 is not the number of electron. 3 only represent the value of charge. Okay, so how can we find the number of electron? So based on this equation, if you can really understand here, okay, it just use the ratio. Okay, so kalau one charge or 1 coulomb, one electron membawa 1.6 times 10 minus negative 19 coulomb. Okay, so kalau dalam 1 coulomb kita ada berapa? Ada berapa elektron? Okay, so from this equation we just divide this number. Okay, so kita ada 1 over 1.6 times 10 minus 19. So kita dapat berapa tu? Ada berapa bilangan elektron tu? Okay, 1 bahagi 1.6. Okay, 1 bahagi 1.6 E negatif 19. So kita dah dapat, kita akan dapat 6.25 times 10 power 18. Maksudnya dalam 3 coulomb. Okay, sekiranya if we provided with 3 coulomb of charge, actually we can get this much of electron. So banyak ke sikit tu elektron tu? Boleh respon seorang? Banyak ke sikit?
Banyak.
Banyak Okay, 6.25. Thank you for your response. 6.25 darab 10 kuasa 18. So 6.25 darab 10 kuasa 18. 6, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 18. Kira lah tu ada berapa trilion tu. Dalam 3 coulomb charge ada banyak ni elektron. Dalam satu coulomb charge. Okay, ini for 1 coulomb charge. So kalau kita ada 3 coulomb charge, darab dengan 3. Okay, itu konsep dia. Itu konsep dia. So maksudnya apa? Bila kita dapat yang ini, this value, E equals to 1.6 times 10 minus 19 coulomb. Okay. So satu elektron dia ada 1.6. Okay. So bila untuk selesaikan masalah yang berkaitan number of electron ni, kita kena tahu, okay, we need to know how much electron in 1 coulomb of charge. Okay, how you can get 1 coulomb of charge? You just need to divide this number 1 bagi 1.6 darab 10 kuasa negatif 19. Ini untuk 1 coulomb. So kalau kita ada 3 coulomb, this value darab dengan 3. Okay. So kalau dah faham ni, okey lah, senang kan? Walaupun tak ingat dia punya formula. Tapi kalau tak faham juga, you can use this formula where Q equals to N and E. Okay. Q equals to Ne. Q is charge, N is the number of electron, and E is the charge for the electron. Okay, E is the charge for electron. Charge electron yang mana? Yang ni lah. 1.6 times 10 power negative 19. So let's look into this example 3. Electric current. So you are given current 3.2 times 10 power negative 3 ampere flows through a bulb for 4 minutes. So dia bagi masa. Determine the electric charge. So how we can get the charge? Ingat kita dah belajar 2 formula hari ini. The first one is QIT and the second one is QNE. Okay, so this is your formula for today. Okay, ada 2 saya susun ni QIT ni sebab kalau kita buat I sama dengan Q divide by T susah nak hafal. Kan? IQT, IQ bahagi T. So panjang jalan cerita dia. Sebab tu saya susun macam ni. Senang. Bila kita sebut je, maksudnya dia berada dalam satu barisan. QIT. So Q equals to IT. Sama macam ni kan? QNE. Q equals to NE. VIR. V equals to IR. Okay? Cara nak senang hafal. So electric charge. So yang mana? Given kita ada current. Current is given. Time is given, and then the question asks for charge Q. So which formula that you want to use? The first one or the second one? Boleh respon seorang?
First one.
First one. Okay Aisyah. Kenapa first one? Kenapa tak guna second one?
Sebab dia dah complete.
Dah complete. Okay, all of the information are given. Kita dah ada information tu kan? Kita ada I, kita ada T, kita nak cari Q. So kita kena kenal pasti. Determine the equation that involve these 3 variables. I, T, and Q. So the first one lah, QIT. Okay, so that's why we're using QIT. And then substitute the value and get the answer lah, the final answer. Okay, if you look carefully here, 4 darab 60 ni berapa? What is this value? 4 times 60. Yang ni kita nampak, kita tahu. This one. Where this is I kan. Maksudnya ini adalah T. Tapi T dekat sini dia bagi 4 minutes. Kenapa yang ni 4 darab 60? Why don't we just take 4?
Dia nak second.
Nak second. Okay, we need to convert into second. Okay, Coulomb, partner dia mesti second. Okay, partner dia mesti second. Ampere, partner dia mesti second. Okay, SI unit. Okay, thank you. Okay, next B, the number of electron. So number of electron, kena tahulah simbol dia apa? It is N. Okay, N. So N, and then we have I, we have T, we have Q. Kan, Q kita dah cari tadi. Okay. And then given also E, we have E. So yang mana antara equation number 1 and number 2, we will choose question number 2. Q equals to NE. So just substitute the value and then you will get the final answer. Okay. So that is for example number 3. Do you have any question? Ada apa-apa nak tanya tak? Tak faham ke? Ada kekeliruan ke? Ada apa-apa nak tanya?
Tak ada.
Tak ada. Boleh faham
Faham.
Okay, good. Thank you Aisyah. Okay, next. Current in electric circuit. Okay, current in an electric circuit. Ini pun sama, hanya revision saja. In electric circuit, current is said a current flow through. Okay, the current is measured by an ammeter. So this one, if you still remember, this is the instrument that used to measure current, ammeter. Bukan ampere. Ampere is the unit. And it must be connected in series. Okay, emitter always connected in series. Okay, how in series macam ni lah. Dia sebaris dengan benda ataupun objek yang kita nak measure dia punya current. Okay. With the component which we want to find the current through the component. For example, if we want to measure the current through a bulb, so macam ni lah. Okay. Dia mesti bersebelahan. Satu line saja, tak boleh dua line dan sebagainya. Itu yang dia masukkan dengan series arrangement. Pukul apa dah tak nampak. Sekarang jam 9.30. Okey lah. Ada setengah jam ya. Okey. So current habis Next physical quantity that we look into today is the potential difference, or also normally known as voltage. Okay, voltage tu nama pasar dia lah, voltage. Okay, but the correct term is potential difference. Okay, potential difference. So how can we define potential difference? Potential difference V, okay, dia voltage kan, dia voltage. So kita boleh lah represent dia dengan V kan. Nama lain dia voltage. So kita dah belajar masa form 1, symbol for voltage is V. Contoh kita nak tulis voltage equals to 5. What is the unit for voltage? What is the unit for voltage?
Volt.
Volt. Okay, thank you Dina. So 5 volt. Okay. So we can also represent all of this notation with V, the symbol for voltage, equals to 5. So what is the symbol used for volt?
V.
V. Thank you Damia. Okay. V. So V equals to 5 volt. Okay, ingat itu simbol-simbol yang kita gunakan. So potential difference, okay, kita boleh tulis sebagai V between 2 points. Okay, normally voltage exists between 2 points. Okay, normally voltage exists between 2 points. Potential difference kan, beza keupayaan. Keupayaan untuk apa? Keupayaan untuk elektron ataupun charge objek bergerak. Sebab tu dipanggil potential difference. Okay, gravity pun ada potential difference. Kan, contoh kalau kita ada satu kawasan tebing tinggi, kita pun letak air dekat sini kan. Okay, letak air. Okay, air ni dia akan ada potential difference. Akan ada keupayaan untuk dia bergerak. Okay, disebabkan oleh gravity. So daripada mana ke mana dia akan bergerak? Dia punya potential difference. From this, of course, air tu dia akan ada possibility untuk air tu untuk jatuh. Bukan possibility, ada tendency. Okay, there is tendency for this water, for this object, bukan air sahaja, to move from this position to this position. Dia ada kebarangkalian untuk dia jatuh. Ada potensi untuk dia jatuh. Okay, so this is the gravitational potential difference. Okay, potential difference. Okay, ada benda yang akan drive this object to move. Sama juga dalam electricity. Kita ada potential difference. Sebab apa kita panggil potential difference? Because this physical quantity will drive any charge object to move. And of course, it will include 2 points, between 2 points. Okay, mesti antara 2 point lah. Okay, 2 point. So for electricity, V between 2 points in an electric field is defined as work. So it is actually work. Okay, it is actually work, kerja. Kerja untuk apa? Work done to move 1 coulomb charge between 2 points. Okay, sebenarnya voltage ni ataupun potential difference ni, it is the work done. Work done ni dah ada kaitan dengan apa? In your form 2 you had learned about work done. It is related to energy. Okay, energy. So work done to move, kerja yang diperlukan, tenaga yang diperlukan to move, untuk menggerakkan 1 coulomb of charge between 2 points. Okay, please be careful. Here is move 1 coulomb. Untuk menggerakkan 1 coulomb. bukan menggerakkan one electron, bukan menggerakkan one charge object. Okay, so here we are using 1 unit of charge, 1 coulomb of charge. So again, voltage or potential difference, it is the work done to move 1 coulomb of charge, not 1 electron or 1 proton or 1 charge object, to move between the 2 points. Okay, that is the definition for voltage or potential difference. Okay, so we can transfer this information into the mathematical notation. So potential difference equals to work done divided by charge, where work can also be transferred, we change to energy required to move one charge from one point to one point. So we can rewrite this information, voltage or potential difference equals to the work done or energy divided by charge, or energy divided by charge, kan? Tenaga per 1 coulomb charge. Tenaga yang diperlukan untuk menggerakkan 1 coulomb charge. Okay, so here we have macam mana kita nak hafal dengan mudah macam ni, VEQ. Dia akan jadi keliru. So untuk hafal dengan mudah, kita susun balik, we will arrange this equation EQV lah. Okay, EQV. So dah ada berapa dah formula kita hari ni? 3. So harap-harapnya ada 3 je lah. Tak banyak. So the first one QIT, second one QNE, and the last one EQV. Rasa cukup kot 3. Dah tak ada dah? Okey, dah tak ada dah. Alhamdulillah. 3 sahaja untuk hari ni. So ada 3 formula QIT, QNE, EQV. Okey. So saya susun macam ni sebab apa? Sekali lagi sebab nak senang hafal, tak keliru kan. Tak adalah nak kena sebut V sama dengan E bahagi Q. Dah makan space dah kepala kita kan, otak kita. Kita nak hafal bio lagi. Ada perkataan bahagi pula ataupun divide kan. So dia kacau space walaupun satu perkataan kan. Tapi ingat, bila kita nak define, we just need to rearrange. Contoh macam ni tadi, I susun balik I sama dengan Q bahagi T. So boleh define current, charge flow, rate of charge flow. Yang ini kita nak dapat definition untuk V. So V equals to, kita susun balik, V as our subject, E divided by Q. Kita ada apa dah? E energy, Q charge. So energy required to move 1 coulomb of charge from one point to another point, ataupun work done required to move 1 coulomb of charge between 2 points. Sama saja. So let's look into the unit. A unit for potential difference, volt, kita dah discuss tadi. Work or energy, joule. Okay, the SI unit. So joule, and the charge is coulomb. So nampak partner dia. Joule mesti dengan second, mesti dengan coulomb, mesti dengan volt. Okay, joule mesti dengan meter, mesti dengan kilogram. Itu joule. Dia tak boleh dengan unit-unit yang lain. Okay, let's look into one example. A current of 8A flowing through an electric heater. So kita ada current. So bila dapat saja soalan, catatkan maklumat yang diberi. So current, kita tak tulis current, tapi kita tuliskan simbol. Sebab apa? Because normally we just memorize the symbol QIT, VIR. Kita tak hafal voltage equals to current times resistance. Kita tak hafal macam tu kan. Kita hafal dia punya simbol. That's why whenever you get the question, just write the information in term of its own symbol. So I equals to 8 ampere. E lah. Okay. Flowing through an electric heater for 50 minutes. So what is 50 minutes? It is time. So T, kita tak letak time. T equals to 50 minutes. Okay. And of course you can directly convert it into the SI unit. 50 meter darab 60 second. So dapat berapa tu? Dapat 30,00 second. Okay. Nak tukar kemudian boleh juga, tak ada masalah. Okay. Pilih saja mana yang kamu sesuai. Convert 5.76 times 10 power 6 joule. So tu benda apa? So bila tengok saja unit joule, we already know that it is the work done or energy. So kita boleh tulis energy sama dengan 5.76 times 10 power 6 joule. Okay. First question, calculate the total charge. So they want us to find the value for charge. Okay. So how can we find the value of this charge? Kita nak guna apa? Based on the information given. Kita ada I, kita ada T, kita ada E, kita ada Q. Charge. Ada berapa formula yang melibatkan charge hari ni yang kita belajar? Ada 3 kan? QIT, QNE, Q equals to E divide by V. So mana satu nak guna? Boleh respon seorang?
QIT.
QIT, okay? That is the simplest one kan? Kalau kita nak guna Q and E, alamak, N tak ada, E tak ada, memang tak boleh lah. Okay? Nak guna Q sama dengan E bagi V. Betul ke E bagi V? Q sama dengan E bagi V, yes? Okay? So, tak boleh, kita tak ada voltage. Kan? Macam nak cari? So, the only one is QIT. Okay, that is the simplest one. So, QIT, dah ada dekat sini. Just substitute and then here, they substitute the value of time in this equation. Boleh, tak ada masalah. Kamu nak substitute awal-awal, boleh juga, tak ada masalah. And then you will get the final answer. And don't forget your unit in Coulomb. Okay. Next one, the potential difference across the heater. So potential difference, what is the unit for potential difference? The symbol for potential difference. Apa dia?
V.
V. So tambah V. Kita nak cari V. So nak cari V, kita dah ada Q, kita dah ada E, kita ada T, ada I. So guna yang mana? Nak cari V. Cari formula yang ada V, yang ada Q. So yang ni kan? Okay, EQV kan? EQV. So ini yang kamu hafal. Tapi dia nak cari V. So just rearrange. E divide by Q. Okay, and then substitute the value. Terus dapat 240 volts. Okay. Okay, do you have any question regarding this calculation? Ada apa-apa nak tanya berkaitan calculation ni? Senang je kan? Senang ke susah?
Senang.
Senang. InsyaAllah boleh jawab soalan lepas ni. Okay. So harap kekal senang lah. Sampai SPM Sampai SPM. IG lepas tu SPM. Okay. So last note. Tadi kita dah tengok how we can measure current. Ini memang biasa, selalu pelajar buat masalah ni. Anak-anak lagi sekarang SPM dah ada practical. Dah ada practical dah. Tahun lepas dah keluar practical electricity. Yes. Keluar electricity. Tahun lepas senior kamu form 5 kena buat eksperimen electricity. Salah pasang ammeter, habislah. Salah pasang voltmeter, habislah. So tadi ammeter, to measure current, we use ammeter and arrange in series. Series tu maksud dia satu baris. Okay, satu baris. So for potential difference of voltage in electric circuit, potential difference across, the potential difference is measured by voltmeter. So we use voltmeter. V, kita gunakan voltmeter. Okay, voltmeter. Itu nama alat dia. And it must be connected in parallel. Mesti disusun secara selari. Dah belajar masa sekolah rendah kan? Parallel macam mana? This is how parallel can be. Okay, dia macam ni lah. Dia bukan sebaris. Dia bukan letak bulb, lepas tu sambung terus voltmeter. So ni salah. This is series. One line. Okay, parallel. Kaki kanan bertemu kaki kanan, kaki kiri bertemu kaki kiri. Maksudnya kaki kiri voltmeter, mana kaki kiri dia? Yang inilah. Bertemu kaki kiri bulb. Dia bertemu kat sini. Kemudian kaki kanan voltmeter, this one, bertemu kaki kanan bulb. Itu dikatakan parallel. Sama juga macam ni kan kalau kita tengok. Kaki kiri bulb bertemu kaki kiri voltmeter, kaki kanan bulb bertemu kaki kanan voltmeter. Kalau series, adakah mereka bertemu kaki kanan dengan kaki kiri? Kita tengok. Kaki kiri bulb, this one, left. Kaki kanan bulb, this one, right. Kaki kiri voltmeter, this one. Kaki kanan bulb, right. So nampak dia tak bertemu. Left tidak bertemu left, right tidak bertemu right. Okay, so this is series. Dia boleh je nak ubah, boleh kedudukan lain kan. Contoh parallel. Dia buat macam ni kan. Lepas tu dia buat letak dekat sini ke kan, voltmeter contoh. So macam nak detect? Kita masih tengok kaki dia. Adakah kaki kiri voltmeter bertemu kaki kiri bulb? Yes. Kaki kanan bulb bertemu kaki kanan voltmeter. Yes. So they are parallel. Okay, they are parallel. Kalau dia tak bertemu kiri dengan kiri, kanan dengan kanan, so they are series. Dia sama ada dua itulah, series ataupun parallel. Okay, so I think we have finished with our session today. Okay, so do you have any question regarding our discussion today? Ada tak nak tanya apa-apa? Ada nak tanya apa-apa tak?
Tak ada.
Tak ada So topik yang senang. Okay, so let's recall back what we had learned today. First, we had looked into the relationship between current, charge and time, where we can get the definition for current. Okay, where current is equals to rate of flow of charge. The symbol used is I, the unit is ampere, which can be symbolized by capital A. Okay, and then we had looked into how we can calculate, we had looked into the relationship between charge, the total charge, the number of electron, and also the charge of an electron, where we can use the equation to find the number of electron flow at certain time, or flow at given total charge. Okay, and then we had looked into how can we measure current by using ammeter, and how can we connect the ammeter. Okay, how can we connect the ammeter correctly, where the ammeter should be connected in series to measure current. And then we had looked into the definition for voltage, where you had been introduced the equation EQV, and then rearrange the equation. We will get voltage equals to the energy used or the work done to move 1 coulomb of charge between 2 points. Okay, so the unit for potential difference is equals to unit for voltage, which is volts, and both symbol, nama dia potential difference, tapi simbol dia masih V, sama macam voltage. Also for volt, the unit is V, capital V. And then we had looked into a few example involving all of the physical quantity that we had learned. Okay, all the physical quantity. So I think that's all for today. Boleh dengar ke suara saya? Boleh dengar tak? Boleh tapi tak jelas Jelas itulah saya punya internet maktab dah terputus. So nasib baik ada backup dekat handset Okay, so tak apalah. Okay, that's all for today I think. Sekejap saya try reconnect sebab saya nak paste saya punya attendance. Kalau tak boleh saya paste dalam Telegram So your homework before our next class. Okay, dah masuk dah. Macam ni. Okay. Your homework saya share balik. Okay, just try to do this tutorial 1. Try to answer all of the question in tutorial 1 objective. Cuba jawab objektif sahaja dahulu. Yang dah siap nak jawab subjektif pun boleh, tak ada masalah. Okay, cuba buat yang objektif dulu. Okay, itu je yang saya minta dulu. Okay, before our next class. And maybe later I will share with you the answer for this tutorial 1. Okay, for this tutorial 1. Sekejap.